Making this video to help you through some of your sample calculations having to do with the first lab of the semester, the decomposition of hydrogen peroxide. So let's just get right started. I'm going to recommend that you launch Excel if you want to follow through and enter in calculations as we're going along, because that's how I'm going to be doing them here. I should say at the same time, you should be as familiar with doing these calculations on your calculator as you are in Excel. It's just easier to show it to you in Excel, and in fact, as I hope to convince you, in lab it'll be way efficient if you are able to do these calculations in Excel. So here's the first sample calculation. If you combined in a test tube, that's how you're going to do this reaction. 4 milliliters of 1 molar hydrogen peroxide, combine it with 1 milliliter of half molar potassium iodide, will produce a what concentration of peroxide and potassium iodide? Obviously, it's going to produce 5 mils total of solution, and we're going to do that. Now, we have a few equations in the lab handout that will help you on this, and the one that is the equation 4 in the handout, which says that if I have a mixture and it has some concentration, C solution, it will be the stock concentration times this dilution ratio. So the stock concentration, for example, of the hydrogen peroxide is 1 molar, and the dilution ratio would be 1 mil that you put in divided by a 5 mil total volume. So I'm going to go to Excel now, and let's see how this works. Now I recommend actually that you stop the, if you haven't already launched Excel yet, go ahead and launch Excel and enter some of these values in here. What you see here is just what we've asked you to enter into table 1, and I'll take you through this as soon as you come back. Okay, so here's the numbers that values that we've got a test tube. Maybe it has a capacity of 35 mils. All of our solutions in this experiment will be 5 mils, so that's what those are. And let's see, we've got trials 1, 2, 3. You'll want to be doing more trials, but trial 1 has 4 mils of hydrogen peroxide, and the concentration of that stock solution is 1 mol per liter. We're going to combine that with 1 milliliter of potassium iodide, whose stock concentration from the bottle is half molar. And I've also added this new column here. We don't know what the temperatures are going to be, but I'm just going to enter in some numbers. So I may as well do that now. Maybe the reaction warmed up when you did it the second time, and maybe it cooled down again the third time. So now let's go ahead and calculate these concentrations. So I remember our formula is stock concentration times a ratio of volumes. So I'm going to go ahead and type in an equal sign, and let's see, this is the mixture of hydrogen peroxide, so I want it to be the stock concentration of hydrogen peroxide times the ratio of volumes. So I'm going to say times. Now what I want here is the volume of H2O2 that I put into the test tube divided by the total volume. That's the volume of the solution, which I have already written down up here as 5. Of course, I could have just written down 5, but I want to show you something. Okay, so there's that. I'm going to just introduce you, or if you haven't already, remind you of this thing called absolute addressing versus relative addressing. If I took this box and, let's say, decided to fill it down, that's where you go to this lower right hand corner and drag down. You'll see that there's a problem that why did it have a divide by 0? Well, you see the formula up here. It took the initial formula was take C9 and D9 and multiply them together and divide by B2. That's fine. But then when I tried to fill down, it said D10 times C10 divided by B3. What's in B3? Well, nothing. That's because I didn't really intend for that to be part of the fill down. So the way you defeat the fill down relative addressing is you put dollar signs in front of it, and that's what I'm going to do now. Okay, and oops, I should have done that on this one. $B, $2, and now when I fill this down, I get some reasonable number. Okay. So that's pretty good. Now if you're feeling good about this, go ahead and enter the expression that you need for the Ki calculation, that is the concentration of Ki in the solution in your test tube after you have combined your 4 mils of hydrogen peroxide with 1 mil of potassium iodide. Okay, maybe you're back. Let's see how I'm going to do it. I'm going to say that is equal to, let's see, the stock concentration of potassium iodide. We said that that's half molar, and I will multiply that by the amount of Ki, that's 1 mil, and I will divide it by my volume of the whole solution. That's that. I'll hit a return, but I want to remember to go back here and put the absolute addressing signs around that. Okay, so that's looking pretty good. There's one other type of fill down that I'm going to show you. You go to the lower right after you've highlighted the box, and instead of dragging, you just left double click, and there we have our 3 concentrations.